Greetings and welcome back to Computer Science Principles. This is Unit 4, Variables, Conditionals, and Functions. Lesson 6, Conditionals Investigate. So for a warm-up, we're going to watch a video that hopefully will remind you kind of what we did last time.
When programming, it is often necessary to establish whether something is true or false, so that a computer can make decisions about what actions are appropriate to take next. For example, when deciding whether or not to provide voter registration information, the computer must first determine if it is true that the person is old enough to vote. This is something that is done using what programmers call a Boolean expression. You can think of it like a yes or no question that the computer can evaluate. It's called a Boolean because it's named after the mathematician named George Boole, who made many discoveries related to working with binary true or false values. In the voter registration example, your Boolean expression might look like this. This asks, is the value stored in the variable age equal to 18? If it is, then the statement is true. Otherwise, the statement is false. Remember, the double equals is the equality operator. It asks if two things are equal or not. If you are using a single equal sign, you are using the assignment operator to set the value of a variable, which is something else entirely. In addition to the equality operator, we can ask questions about if one value is greater than or less than another value, and these are called comparison operators. If you saw the statement 3 less than 2 in math class, you'd think something was terribly wrong. But this is still not math class. In programming, you use the comparison operators to ask the computer a question, which it can answer true or false. So with this line, the computer sees you asking, is 3 less than 2? The answer in this case is no, or false. We can use a comparison operator in our voter registration example to make the program even more accurate. Because it's not just 18-year-olds who can vote, it's anyone whose age is 18 or older. So the questions you'd want the computer to evaluate should be, is the user's age greater than or equal to 18? Like this. Now that we can express the question, we can have the computer actually do something depending on whether the answer is true or false, such as displaying the registration info if true. We'll learn more about how to do that next.
All right, so with that, let's go ahead and think about this real quick. So in your journal, you should see that there's a box in there that you can double click, add, insert a drawing to, and kind of think about this or just kind of draw it out. But a water park will let a visitor on a ride if they are 48 inches or more. So remember what or more means, greater than or equal, or they are 14 years old or older. So again, greater than or equal to. But this is the or. If you remember back to what we talked about, there's the and, there's the or. Or means only one of those needs to be true, right? Either or. So we have our symbols down here. Go ahead, give you some time to create this little flow chart. If you remember from last lesson how to create those. So pause. Welcome back. Again, hopefully you just have one big statement that says 48 inches height, greater than or equal to 48 inches, or, this is the or, age is greater than or equal to 14. So we got to think about when we're going through this, there's some key words and wording, I guess would be a way to say it. When means that there's an on event to respond to user input. So the app does something when a user clicks, when a user hovers over, right? If means there's a conditional statement that decides a piece of code to run. So if this is true, execute this code. So again, when this happens, if this is going to happen. So on the on event, you're going to be hearing when, but the conditional statement is going to be if. So good to understand about that. All right, so we got a video, and then we're going to go ahead and practice some of this.
Our daily lives are filled with decisions, big and small. Even simple choices like what to wear usually are the result of complex considerations. What's the weather going to be like? What will you be doing today? Do you feel like making an impression or keeping it casual? But the world around us is constantly changing, so we want to adapt the choices we make to match the changing conditions. What's true for humans is also true for computer programs. We don't want our programs to always run in the same way. They should respond to changing conditions. In the last video, we learned how to use Boolean expressions to establish whether something is true or false. We can now add something called a conditional statement to help guide the computer's decisions based on that information. The simplest conditional statement is an if statement. It says that if something is true, the computer should run a specific block of code. Let's say that you want to create a program that displays whether or not you are old enough to see a PG-13 movie. So the question we want the computer to evaluate is, if age is greater than or equal to 13. The question, or Boolean expression, goes next to the if. The block of code we want to run, only if the condition is true, goes inside the if statement. So in our example, whenever the expression age greater than or equal to 13 is true, the program will write to the screen that you are old enough to see a PG-13 movie.
All right, now we're going to kind of bounce back and forth through things. So if you go to Lemon Squeeze Part 1, so this is where you go to code.org. This is level 3. You're going to kind of look through this code. So play the game at least once. And then if you have a partner, do this. Otherwise, just choose some lines of code. All of this is also in the code.org. And then you're going to think about it or discuss it if you can. Explain what your section does. And then ask it questions. I understand this line. What does it do? So think about what's going on. Confusing. Write those down for later. And here's the kicker at the end. Modify the program. Keep going when the player has 0 lives. It's fix the problem, right? So if we play this game when the person has 0 lives, it keeps going, right? I think I might already have this fixed. So when we're looking through this, when you run it, play it. So hopefully you played it a few times. You're checking to see if you can get it to work. All right, that's kind of what it's doing now. It's discuss, modify. Right now the game keeps going when the player's lives. Fix this problem. So you got to stop it when it goes. So there's a lot of lines of code to this. I want you to look at this and kind of figure out what's going on. How do you use it? How do you work with it? Restart it. I think that was a problem. Figure out exactly why this is working or not working. So I'm going to pause here. All right, welcome back. Hopefully you're able to figure out how to fix this. And you kind of see how these if statements work. Show blocks. So hopefully you're looking, you ran through the code, you understand what the event things do, right? Play, starts, resets everything for you, sets all your thing, and then kind of gets the game screen going. And then you have mouse over, so that's when you just hover. Mouse over is just hover. So when you're hovering over it, your score goes up. And then it moves the lemon. So basically you just kind of hover over it, moves the lemon, and so on and so forth, and kind of same concept. There's different lemons, and then you're going for that. So again, if you hover over the wrong one, if you hover over lime, your lives go down. Your score goes up if you hover over lemon. That's what this code's doing. So as we go forward, we'll watch a couple more videos, but then you're going to kind of keep playing with this app.
Of course, some people will not be old enough. In these kinds of situations, we will want our programs to do something else when the condition is false. In order to do this, we will want to expand our if statements to include an else statement. The commands contained in this else statement only run if the Boolean condition in the if statement is false. In AppLab, you can add an else statement by either dragging out the if-else block or by clicking the plus symbol in the bottom right corner of the if block.
So pause it right here because this is important to understand. Remember, the if statement, it only executed if it was true. And then if it wasn't true, nothing happened. So now what we're able to do is, hey, if it's true, do this, else do something else, right? So no matter what, if you have an if-else statement, doesn't matter what you have. If you have an if-else statement, some code is going to happen, something is going to execute, because either it's true and it'll execute the first one, or else, and that's why they use else, or else it will just execute the rest of it. So with an if-else statement, you can always, and you don't always need that, right? Sometimes you're like, hey, if this is true, execute this code. Otherwise, do nothing, right? There's no else. Just keep going. Don't do anything if it's false. All right. So another video, and this is adding a little bit more complexity to it. So you can just do if it's this, else if it's this, and then else. And as we go through, it's important to understand that you can have an if-else statement, you can have an if-else-if statement, you can have if-else-if-else statements. Again, it's else is only there if you want it to do something if everything's false, right? That's the whole point of an else statement. If everything above it is false, it executes. But you don't need to put it in there, just like in an if statement you don't need to. So you don't always need to have all of this. It's really what you need to do with your program.
Sometimes the decisions you will want your program to make have more than two possible outcomes. Let's continue our movie rating example, where we want to check whether the highest rating you can go see alone is an R-rated movie, a PG-13 movie, or just a G-rated movie. To check between these three different cases, we can add an else-if statement. An else-if statement is another condition that a program checks only if the previous if statements were false. So if age is greater than or equal to 17, write that user can see an R-rated movie alone. Else if the age is greater than or equal to 13, write that the user can see a PG-13 movie alone. Else, write that the user can see a G-rated movie alone. The else condition becomes the default condition because when all the previous if and else if statements are false, it will default to the else statement. Be careful as you construct longer sequences of else if statements. If you mix up the order, you might not get the behavior you intended. In our example, imagine we had switched the code so that the first condition checked if the user was old enough to see PG-13 movies, like this. This would mean that everyone who is 13 or older would be told they can only see PG-13 movies, even the adults. And with the next else if line, the computer would be looking for people 17 or older in the remaining group. This code misses the adults because they were true in that first condition. This won't work. The computer checks the conditions from top to bottom, so it is important to enter the most specific condition first.
And that is an error I see a lot with students, is not having them in the right order. Whatever you're checking, greater than, less than, that is a big issue. All right, so now we're back to our lemon squeeze. You're going to play the game once. This is on level 6. We get some else-if statements. So again, you read what it wants you to do, kind of draw out a flow chart for it, and you're going to modify the program so lemon becomes even smaller when it's 15 points. So if the score is greater than this, we're going to make it smaller. All right. So as the score gets greater, it's going to, and they already have if it's greater than 10 and greater than 5. So play it, see kind of what it's doing. You're just going to add a little bit more so it gets even smaller and it shows you what to do. right here, right? You just got to move some stuff around. And sometimes it's easier to do this in show text because you can just add an else to this. But your goal is to make it even smaller when your score gets above 15. So go ahead and pause. Welcome back. Hopefully you're able, again, just make that so you add an else here. Enter if score is greater than 15, set property lemon width, I don't know, 10 because you're evil. Set property lemon height 10 to make it super small to try to get. Again, you're just shrinking the lemon, the lime. You can actually probably even want to, if you wanted to, make the lime bigger, but that's not what we're doing. Just had to do that. So on to the next video where we start putting it together with the or and statements that we talked about.
You can add even more complexity to your conditional statements by asking two questions at the same time. We use the and or operators to check two Boolean expressions at once. Let's talk about or first. If we wanted to, for example, express that you can be younger than 5 years old or older than 95 years old to get free admission to a museum, we could express that like this. Expressions that use the or operator are true if either the first or the second expression is true. Only when both expressions are false does the ORed expression evaluate to false. The AND operator is more strict. What if we wanted to say that to get the student pricing at the museum, you need to be between 12 and 21 years old? We could express that as checking whether age is greater than 12 and age is less than 21. If only one of these conditions is true, that's not good enough. Both conditions must be true to get the student discount. More and more complex questions can be represented with combinations of and or statements. What if the museum gives the student pricing to everyone, if it's Tuesday or Thursday? But on every other day, you still need to be between the ages of 12 and 21 to get a discount. We could express that like this. If the day is Tuesday, or the day is Thursday, or your age is greater than 12 and age is less than 21, then you get the student pricing. Else, you get regular pricing. When using text, use parentheses to group Boolean expressions together. When evaluating this complex conditional, the computer will evaluate each Boolean expression separately, and then use the rules of and or to determine if the whole expression is true or false. So if the day is Monday and the user is 25, the code would run like this. First, the computer checks if the day is Tuesday. It's not, so that is false. Then the computer checks if the day is Thursday. It's also not, so that is false as well. Since it's not Tuesday or Thursday, and at least one side must be true for an or statement to evaluate to true, that whole expression evaluates to false. Then the computer checks the other side of the or, since that could be true. The computer checks if the age is greater than 12. 25 is greater than 12, so that statement is true. Now the computer checks if the age is less than 21. 25 is not less than 21, so that statement is false. Since this was an and statement, but only one side was true, this whole expression evaluates to false, and the message displays that the user gets regular pricing. For a human, perhaps this answer was obvious from the beginning, because we are actually pretty good at dealing with logic statements when they represent real-life decision-making. But the computer needs to evaluate every expression until it can determine whether the condition is true or false. Many beginner programmers make a mistake while trying to write this expression. Is the day Tuesday or Thursday? Notice the subtle difference between the correct code and this version. This is often the result of the fact that in English, we would say, is the day Tuesday or Thursday? However, remember that computer questions are different, so we have to ask, is the day equal to Tuesday or is the day equal to Thursday? So that the computer will understand. Computers do exactly what we program them to do, but with conditionals, we can simulate complex decision-making and have the computer adapt to changes, or even seem intelligent to humans.
All right. So, part 3, again, head on over here, go to level 8 this time. You're going to play the game once. We're going to find the if-else-if statement that was added. You're going to draw your nice little flow chart. You're going to modify the app to add one more username and password. All right. You need to edit the code, both the code and the user interface. Warning, use a fake password. Don't use your real password. So, again, we have a username and password in here. All your directions are there as well. Let's show blocks so you can see it better. All right, so this is all the game button, right? So if we look at this, this is play button. It's getting the username and password here. It's checking if username equals Lemonhead and password equals Lemon123. Go to the game screen. Else if username is Mellow Yellow and password is something, go to the green screen. Otherwise, it's not going to go to the game screen. And the game won't play, right? All the rest of these buttons are on the game screen, so nothing else will happen. So it wants you to add one more else if statement with a fake username and password. Also, you'll notice that you'll need to add a drop down, right? So you don't even have to type in the username, right? You just have to add the drop down. So you need to add all that to get done things. So go ahead and pause here. All right, welcome back. Hopefully you'll figure out how to add that. And again, you use this to add more to this. It's got to copy the code from above. And let's kind of wrap this up. What is the difference between an if statement, an if-else statement, and an if-else-if statement? How are they similar? And again, this doesn't even go over the if-else-if-else statements, right? How do they work? How are they similar? What do they do? So go ahead and pause. Welcome back. Hopefully you kind of notice the if statement. They all have if, right? So they all check first if the first statement's true, but then that's where the first one stops. The second one will execute some code if it's false. The third one will check a second conditional and see if it's true or false and execute it. But it doesn't have a false statement. So if anything's false, it will execute. And that's why I said there's also the if-else statement. So with that, again, multiple conditions. If, else, if, else, if, else, if, else. This is the statement I was talking about, where you have that else at the end. You'll evaluate all these. If they're all false, it'll just execute that. So with that, that's the end of the lesson. We'll see you next lesson. Have a good one.